Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd edition by Briggs, Cochrane, and Gillette. The point of this video is I'm going to work a couple examples. Actually, I'm going to work the same example both ways that we discussed in our previous series on what a derivative is. And I'm going to focus this video on the function f of x equals 2x cubed minus 5. And my question is going to be, what is the slope of the tangent line when x is 3? In those video series, I introduced the idea that the slope of the tangent line could be written as dy dx. And we understood that to be, that was the limit as this horizontal distance delta x goes to 0 of the change in y over the change in x. Now, I want to introduce one more piece to this puzzle. This is denoted as Leibniz notation. There actually is a Newton notation, but no one ever uses it because it's silly. And then the other one that you're probably going to start seeing is f prime of x. That's just a little apostrophe hanging out there. What that means is this is the derivative of x, and this is Lagrange notation. And we're going to talk, this is also a very common thing. So here we could say, if I wanted f prime of x, and I want to know when x is 3, I could write that as f prime of 3. And that works just like a function notation. What we're going to see as we move forward is not only can I think about the derivative as a slope at a point, but I can also think about the function as the derivative as a function. And we're going to talk about that more in coming videos. So, I have now completely ruined this piece of paper, so we're going to continue on this next one. And the idea is I'm going to work this using both definitions of the derivative we developed in the last few videos. I'm going to start with the traditional definition. So I'm going to say dy dx is the limit. Already messed up. It's the limit as h goes to 0 of f of x plus h minus f of x over h. And if you'll recall, really what I did here is I said x plus h minus x, and that just leaves me with h. Now, from here I'm just going to substitute in. So I've got the limit h goes to 0 of 2 times x plus h cubed minus 5, that's my first term, minus 2x cubed minus 5, and that's all over h. Now, before I go and start expanding this out, I want to go ahead and note negative 5 minus negative 5 is 0. Those cancel each other out. Now, here comes that unfun part where I have to expand x plus h cubed, and I'm going to use the binomial theorem to do that. So that's the limit h goes to 0, and I have 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x cubed all over h. Now, if I distribute in this 2, I've got, so that's the limit, h goes to 0, 2x cubed plus 6x squared h plus 6h squared plus 2h cubed minus 2x cubed, and I'm hoping that you're paying attention and notice, hey, Mr. Garwood, check it out. I've got 2x cubed minus 2x cubed. Those two cancel. Now this leaves me, and I'm going to go ahead and factor out an h because all three remaining terms still have an h. I've got limit h goes to 0, h times 6x squared plus 6xh plus 2h squared all over h. Now, I have a limit, which means I'm not concerned when h is 0. I'm more concerned with what's going on very close to when h is 0. So I can pretend that those two don't exist and just evaluate the limit as h goes to 0, 6x squared plus 6xh plus 2h squared. Now, notice this. H goes to 0. I have no domain restrictions. I can just plug in that h is 0. Well, if h is 0, these two terms are 0, and I am only left with 6x squared. Now, this would actually be the function that's the derivative, but if we go back to our original question, we asked the question, what is the slope of the tangent line when x is 3? Now, we just said that dy dx is 6x squared, and what I do, I'm going to add something here. I can say that dy dx when x is 3, so notice here I just put a little slash and say when x is 3 is 6 times 3 squared. 3 squared is 9, and 6 times 9 is 54. And there's our answer. Now, you may be sitting here looking at that going, sweet sassy lassie, Mr. Garwood, that was a lot, and I agree with that. But that is working through a process, a very relatively complex derivative question. So, what I'm going to do now is I'm going to work the exact same problem, except this time using that alternative definition of the derivative. So, once again, we're focusing on f of x is 2x cubed minus 5, and I want to know what's the slope of the tangent line when x is 3. Notice this are exactly the same. Now, how I'm going to do that, I'm just going to say that's the limit as x goes to 3, so I'm focusing in on the point 3 of f of x minus f of c over, or excuse me, that's 3 over x minus 3. Well, let's go ahead and change over to blue. Now, f of x, we said, is 2x cubed minus 5. F of 3 is 2 times 3 cubed minus 5 all over x minus 3. This is really tempting for me to actually evaluate that using my calculator. I don't want you to do that. I want you to leave it like this. Now, we're going to notice once again, like we did in the last one, I've got -5 minus -5. Those are 0. And as I rewrite this, I'm actually going to factor out a 2 off of the top, because both of them are multiplied by a 2. So that's 2 times x cubed minus 3 cubed over x minus 3. And I can actually use my laws of limits to say that that is double the limit. X goes to 3, x cubed minus 3 cubed over x minus 3. Now here's one of those moments where that old algebra is coming back to roost. I've got the difference of 2 cubes, and using my rules about the difference of 2 cubes, I can rewrite this, forgot my 2 out front, as x minus 3 times x squared plus 3x plus 9 over x minus 3. And hey, look, we're right back to that situation where on top and bottom, these two things are the same. Now, I'm not concerned with when x is exactly 3. I'm concerned with what is this thing doing as it gets really, really close and what's going on around it. So here I've got 2 times the limit as x goes to 3 of x squared plus 3x plus 9. Now here, I have no domain restrictions. I have no problems. This is a polynomial. Going back to section 2.3, we said that, hey, look, if I've got a polynomial, I can just plug in 3 to evaluate this. So that's 2 times 3 squared plus 3 times 3 plus 9. 9 plus 9 plus 9 is 27. So I've got 2 times 27, and that's 54. Oh, wait. We just got 54, didn't we? So regardless of which way I evaluated this limit, I got that the slope of the tangent line at that point was 54. I hope you have found this video useful, and good luck in this semester.